This is a super important lesson where we discuss the technique called as Precedence Diagramming Method, abbreviated as PDM. This is the core technique used to create the schedule model for your project. On the screen, you can see a very simple example of such a model. Here, the activities are represented as nodes and they are logically linked to one another with these arrows. These arrows or directional links are called as relationships and they show the sequence in which the activities are to be performed. The way to interpret this simple diagram is activity 1 will be the first to be started, and after it is completed, only then is activity 2 started and completed. And finally then activity 3 is executed. So logically, activity 2 is dependent on activity 1 and activity 3 is dependent on activity 2. Activity 1 does not have a predecessor. It has one successor, which is activity 2. Similarly, activity 3 does not have a successor, but it has a predecessor. Activity 2 has a predecessor and a successor. A key point to note is that we have to avoid redundant relationships. It must be already in your mind that activity 3 is also dependent on activity 1, which is true, but we should avoid redundant relationships. Now, here is a realistic example of how such a schedule model will look in scheduling software such as Microsoft Project. This is exactly the same logic from the previous slide. The screen is split into two parts. On the left are the activities, also called as tasks, and on the right are the same tasks represented as nodes, which are graphically linked to each other with the directional arrows called as relationships or dependencies. Now, why do we even have to do this kind of a precedence diagram? Because Microsoft Project can then automate the entire thing for you. For example, suppose at some point of time, let us say this task got delayed by a couple of days. Okay? And project can automate everything for you. Precedence Diagramming Method, PDM, includes 4 types of universal relationships. You can apply this foundational logic to any schedule in the world. I will show this logic with Microsoft Project. I will refer to our ongoing EHR project for all the examples that will follow. As I give these examples, observe the links and the activities. The first type of relationship is called as finish to start FS. Here, the successor activity cannot start until the predecessor has finished. For example, we have to finish the staging server trials before we start the production servers. This logic is the simplest to understand and the most common in the real world. The activities will run one after another serially. The second type of relationship is called start to start, SS. Successor activity cannot start until the predecessor activity has started. For example, new branding for the EHR cannot start until the consumer data migration has started, but then it can run in parallel. The third type of relationship is called finish to finish, FF. Successor activity cannot finish until the predecessor activity has finished. An example for this is we cannot consider production testing as completed until the production server infrastructure is fully set up. Here too, the activities can run in parallel. The fourth type of relationship, and the strangest and the rarest of them all, is called as start to finish, SF. The successor activity cannot finish until the predecessor activity has started. For example, the new EHR application has to launch properly before we shut down the older legacy hospital applications, thereby ensuring zero downtime. Okay, that is an example of SF. So these are the 4 horsemen of the PDM technique. These are foundational concepts and you should digest this very thoroughly. The FS relationship, that is this one, is the most common and it's applicable perhaps 90% of the time. The SF, on the other hand, is the rarest and you should never use it unless the situation specifically demands it. If you use SF in your schedule, you will be demanded an explanation from whoever reviews your schedule. Okay? So, a couple of final points before I wind up this lesson. First one, sometimes 2 activities can have multiple relationships. For example, SS and FF can exist together in the real life. But as a rule, you should avoid multiple relationships because it constrains your automatic scheduling. In that situation, what you have to do is you have to choose any one relationship that best fits the logic. Second point, you should never have a closed loop in your relationships, as sometimes when you are working this out in paper, you may inadvertently get into. Fortunately, modern tools like Microsoft Project prevent this happening in the system, and it will prevent you from running around in circles. Okay, and with that, I will close this lesson. Coming next up, we will learn about dependency, determination, and integration technique, which will give you a strong real-life understanding of logical dependencies. So see you there.